Okay, in this video I'm going to take a look at RStudio, which is useful for running RScript. And in this particular set of scripts that I will paste in, I'm going to explore visualization, which I've taken from chapter 3 of this book, and I'll leave below the video here a link, a hyperlink to the textbook. But let's just go and find that particular textbook, online resource, and so I'll just paste here, paste and go, and that brings us to data visualization. It's chapter 3, and the textbook is R for Data Science, and the book is authored by Garrett, Grohlmund and Hadley Wickham. So this R for Data Science is, well, importantly free to use and has part of the Creative Commons licensing, and will always be free. And it introduces a number of areas, but in particular Tidyverse, right, which is important for exploratory data analysis. And might just explain a little bit what Tidyverse is. Tidyverse is a suite of packages that were developed by Hadley Wickham and Garrett Grohlmund, and Tidyverse is a set of open source or packages introduced by Hadley Wickham, who is a statistician from New Zealand and is quite prominent in terms of developing packages for RStudio, and his team that share an underlying design philosophy, grammar and data structure of tidy data. So you can follow the links here. The core package are ggplot, dplyr, tidyr, readr, purr, tibble, stringer and forcats, and each of these are packages that have been developed by that team, and they sit in a suite called Tidyverse, and they're very useful for visualization and for manipulating data, for putting data into categories, for reading data in from different data sources, for organizing data in terms of data tables. The table is a new data table type format introduced by in the Tidyverse package. So to leverage a little bit then this resource, we can go to this HTML reference, and I'll come down to data visualization. And the data visualization, it largely uses the ggplot2. It's one of the most elegant and most versatile of the packages. ggplot2 implements the grammar of graphics, a coherent system of describing and building graphs. Okay, with ggplot2 you can do more faster by learning one system and applying it in many contexts. So from my perspective, ggplots, what it offers is strong visualization, and it allows us to explore data sets and develop high resolution type graphs like this, which if we use the MPG dataset, which is internally available in the ggplot package, then we can map out the engine size in terms of liters relative to fuel efficiency. So if I go into the RStudio and just run the code here, first of all, to invoke these controls, the ggplot, and call up the data set and then plot the XY data, X being the engine size and Y being the fuel efficiency. Okay, we need to first install the Tidyverse and then invoke the Tidyverse or make it available. Library would imply we make the packages available within RStudio. Now, I've already installed Tidyverse. How do I know that? Well, if I come over here to packages and then come down, they're arranged in alphabetical order. I can come down to Tidyverse and I can see that suite of packages is available here. So user guides, vignettes, and the Tidyverse and so on. So all that, some of the philosophy here in terms of how the packages are organized, I can interrogate. And then to call in the tidy package vignettes and instructions and to make it available to this R script, I must use library Tidyverse. Now the data, okay, so if I run that data install, it wouldn't install the suite. There's no need for me in this case because I would have to uninstall and reinstall, so I'm not going to pursue that, but I will make the library available, and if I run that library, that has the effect of ticking the Tidyverse box. So basically Tidyverse, which we saw here a second ago, Tidyverse, here if I run library, okay, we can see that the Tidyverse is ticked. Right, so that library is now available. In the ggplots, we have a data set, MPG, and then if I run, I can see it loads into a table. Right, normally in base R we would have data frames, but here data tables. But here we get tables, which are kind of an efficient way of organizing data. And we can explore that data a bit further. Data, it appears here, and then the structure of the data. And we can just take a look. Basically, we have data relating to the manufacturer of the different models of cars. With the model of car, with the engine size in terms of number of liters, the year, the number of cylinders, the transmission, is it manual, automatic, the drive, forward wheel, rear wheel, or four wheel, the level of efficiency in the city, level of fuel efficiency in terms of miles per gallon on the highway, then the fuel type, is it petrol, diesel, electric, and then class of car, compact, subcompact, middle-sized vehicles, and so on. So some of that I've included in here in terms of just the description of the data that we have. Okay, if we want to view the data in terms of a relational database, again, we can see here we have 230 observations, so 234 observations, each with 11 variables. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then the data, the variables are the columns. So we have observation 1, observation 2, observation 3, all the way up to 234. It's not a large data set, it's actually quite small. In each instance, we can see we have the manufacturer, and we have the model type, the size of engine, the year, the model came onto the market, the cylinder, number of cylinders, and so on. We could also, if we filter here, we can do something that we easily implement in terms of Excel. For instance, we could look at the number of cylinders. The smallest number of cylinders is 4. If we arrange in terms of descending order, the largest number of cylinders is 8. So minimum would be 4, maximum is 8. In terms of fuel efficiency in the highway, minimum fuel efficiency is the Dodge Dakota pickup 4-wheel drive. It only gets 4 miles per gallon on the highway. In contrast, the Volkswagen Jetta gets 44 miles per gallon on the highway. And again, this is a useful way of looking at the data. Now the data is, one would expect that we would get some kind of relationship where as the engine size increases, the level of fuel efficiency drops. And that would come from prior knowledge, but can we observe that from here? And how do we model that? Well, we could just try to explore the data in terms of, well, we look at the structure of the data, so what's on offer here. There's a limited amount in terms of what it reveals, but it does tell us the type of, is the class a character, is it an integer, what type of variable is it, do we have numbers. We can get the basic descriptive statistics by invoking summary miles per gallon. That's from base R. And again, you can see if we look at the engine size, the 1.6 litre is the smallest, the maximum is 7, the median is 3.3, the mean is 3.472 litres, and so on. So that's also very useful in terms of exploring the data. And then the hashtag or the pound symbol, we can leave comments. Comments are very useful for revealing what it is we're trying to explore. So among the variables in MPG are the engine size, the fuel efficiency, and so on. We want to explore that relationship, and a ggplot graph could actually reveal something here. So I'm going to run the first graph here. Again, the package that I have in mind that we're using is ggplot. We might take a look at that ggplot. So ggplot, and we have ggplot2, and we can take a look at what it does to create elegant data visualizations using the grammar of graphics. So I'm going to run here the 2 lines of code, and what I get out is the relationship between the engine size and the fuel efficiency. And it's fairly clear, looking at this data, that we have a negative relationship, or an apparently negative relationship between the engine size, the number of litres in the engine, and the highway efficiency. So as the engine size increases, for our 234 observations, we seem to get a pattern of reduced fuel efficiency. There are a few outliers here that are a little bit puzzling. One of the nice things about ggplot is we can break down our data, and we can, from the graphing, we can reveal through color, through breaking the different classes and so on, breaking the data down to different categories. We can break apart patterns here. So I'm going to see if I can explore what might be going on here in the outliers. And I just add in a small bit of extra code. So basically we're saying pull in the data from the MPG data set, and then the geometric point. We use points here for identifying the data points, and then the mapping aesthetic was an XY scatter graph. And in this instance, I'm saying, okay, for each of these observations, identify the class by a different color. Okay, so we run the ggplot, and again, when we run that, we get the same graph, but interestingly, we get here a legend for the class of vehicle. So it's 2-seater, compact, mid-size, minivan, pickup, subcompact, and SUV. And we notice here for these outliers, they're kind of a red color here. These are 2-seaters, and so some of the 2-seaters have actually very large engine size, but the vehicles are probably quite small, and that might account for the improved fuel efficiency. So again, if we start with the view, if we had our prior knowledge suggested that larger engine size indicates normally higher, or is associated with a lower level of efficiency, higher engine size, lower level of efficiency, we can kind of understand that purely by identifying a separate coloring here for the different data sets. So this is just the first video in a series of 2 or 3 that I will post, and I just have done a brief introduction to Tidyverse and ggplot.